Dear students, in this lecture we are going to discuss about the formal definition of a limit and the properties of limits, or we may call them as rules for finding the limits. As we know, the informal definition of a limit from the previous class, that is limit extends to a f of x is some L. So what does it mean? So f of x is closer to L whenever x is sufficiently closer to a. So your f of x is not defined at x equals to a also. No problem. So your f of x is in the neighborhood of L, then x is in the neighborhood of a. Here the meaning enti the value of x, then it is nearby a, it is the neighborhood of a, then f of x is in the neighborhood of L. So with the same concept we need to define this formally. So the formal definition of the limit. See the definition. If for every epsilon greater than 0, then there exists a corresponding number delta greater than 0 such that for all x, 0 is less than modulus of x minus a is less than delta. That implies mod f of x minus L is less than epsilon. So here mod f of x minus L is less than epsilon whenever x minus a is between 0 and delta. So if we express this as, so here so we know the mod x is less than k, that means minus k is less than x is less than k, right? So by using this formula you can express this mod f of x minus L is less than epsilon, and similarly this also. So mod x minus a is less than delta means minus delta is less than x minus a is less than delta, right? That implies mod f of x, so it is in the form of mod x is less than k, so we can express it as a minus epsilon is less than f of x minus L is less than epsilon. Alright, now so here see, here we can transpose this a to left and right, or adding a for the entire inequality, so that it is a minus delta is less than x minus a plus a, means it is x only, less than a plus delta. This implies here in the same similarly, so adding L on both sides or for the entire inequality, so that it is L minus epsilon is less than f of x is less than L plus epsilon. Now so here so you can observe the definition. So the value of x is between a minus delta and a plus delta, then f of x is between L minus epsilon and L plus epsilon. Indirectly it says that f of x is in the neighborhood of L minus epsilon, L plus epsilon means, so here the value of f of x is in the neighborhood of L only, right? And so whenever x is in the neighborhood of a, అంటే వల్ల x వాల్యూ అనేది a మైనస్ డెల్టాకి a ప్లస్ డెల్టాకి మధ్యలో ఉంటుంది. As f of x is f of x value is between L minus epsilon and L plus epsilon. So indirectly, so this says informally, f of x is L when x is a. That means the value of f of x is in the neighborhood of L when x is in the neighborhood of a. So to show mathematically, so we need to consider these two elements, epsilon and delta, two numbers epsilon and delta. So these two things are very very small. Like yesterday example, like delta equal to 0.1 తీసుకున్నాను కదా, సో అదే విధంగా సో epsilon and delta are very small. So this is our mathematical definition or the formal definition of a limit. See here, so we can note one point. The formal definition of limit does not tell how to find the limit of a function. So but it enables us to verify the suspected limit is correct or not. So here, so by using this definition, so just we need to show whether the limit is correct or not. So let us take one example. Show how to apply the formal definition of a function. See here, show that limit x tends to 1, 5x minus 3 is equals to 2. So now we need to show the limit of this function is equals to 2 using the formal definition. See the solution. So here you can compare the given limit with the informal, like limit x tends to a f of x equals to L. So here what is given? Given that here f of x is 5x minus 3 and a is 1 and L is 2. Now, so what is our formal definition? So write down the formal definition for the given function. For a given epsilon greater than 0. So here what we have to find? So we have to find a suitable number delta, right? A suitable number delta which is greater than 0, so that if 0 is less than modulus of x minus a means 1 is less than delta, then modulus of f of x minus 2 is less than epsilon. So a is 1 and L is 2. Already we know f of x is also. So here so we need to find this delta. So by working backwards from the inequality, epsilon inequality, to show whether the limit 2 is correct or not. Here what does it mean? Here mod f of x minus 2 is less than epsilon. So whenever mod x minus 1 is less than delta. So here we need to show from backward. Now, so it is mod f of x minus 2 is less than epsilon. So that implies or this is, or you can write like so mod f of x minus 2 is less than epsilon. So what is f of x here? So this is a 5x minus 2, sorry 3 minus 2 is less than epsilon. This implies modulus of 5x minus 5 is less than epsilon. So we can express it as 5 times of mod x minus 1 is less than epsilon. So dividing on both sides with the 5, so we get this as a mod x minus 1 is less than epsilon by 5. So already epsilon is a small number. Epsilon by 5 is also a number. So thus we can take delta is epsilon by 5, or any small positive value also no problem, or any smaller positive value. So here so this proves limit x tends to 1, 5x minus 3 is equals to 2. So where epsilon and delta are smaller values. So here we need to show like this. So mod f of x minus L is less than epsilon whenever mod x minus a is less than delta model. So for that just you need to consider this epsilon inequality, and so you need to show it for like it is a modulus of x minus 1 is less than delta form, where delta is equals to epsilon by 5. Hence it is proved. So the next thing is properties of limits. So here we need to state some rules to calculate the limits for the functions. So that are arithmetic combinations of functions. So whenever whose limits are unknown, See here, the arithmetic combinations means addition, subtraction, multiplication, and division, or it may be power also. So whenever, so we know their limits individually. So here, if so capital L, M, and small a and k are real numbers, and the limits for f of x and g of x are also given, like a limit extends to a, f of x is L, and a limit extends to a, g of x is M. Then the properties. So then the first one is sum rule. So here, what is the sum rule regarding f and g? So here it is a limit extends to a, f of x plus g of x, f of x plus g of x. So here, so the limit extends to a, f of x is given, and limit extends to a, g of x is given. If the function, the limit is like this, like f of x plus g of x, so we need to apply the limit for both the function individually. So that means limit extends to a, f of x plus limit extends to a, g of x. So that means L plus M. Limit extends to a, f of x is L, limit extends to a, g of x is M. Next, similarly, difference rule, right? Difference rule. So that is limit extends to a, f of x minus g of x form. So this is L minus M. So here similarly we need to apply the limit for f of x and g of x at x tends to a. Then product rule. So f and g are in the product form. So how to apply the limit? So that is limit extends to a, f of x into g of x. So similarly we need to apply the limit for f of x and g of x. So if we apply the limit for f of x, so we get L, and if we apply the limit for g of x at x tends to a, this is M. So therefore it is L into M. So next, constant multiple rule. So if the function is multiplied with a constant, then see how to apply the limit for that function. So limit extends to a, k into some f of x is there. So already we know the limit of a constant function at any number is always k only. So similarly here we can express this as, so k into limit f of x at x tends to a, that is k into L, where any number, k is any number. Next, quotient rule. You know the quotient, that is in the form of f by g form. So if the function is in the form of f by g, then how to apply the limit for that entire function? Limit extends to a, f of x by g of x. So here we need to apply the limit for numerator and denominator. So if we apply the limit for this numerator, that is limit extends to a, f of x divided by limit extends to a, g of x. So numerator is L and denominator is M. And so finally the power rule. If the function that contain a power, then so you need to apply the limit for that as like this. So if it is in the form of limit extends to a, f of x whole to the power of some m by n model. So here m and n are some integers. So this is, so here you can apply this limit as limit extends to a, f of x whole to the power of m by n also. Means it is L to the power of m by n. So here, these properties will use to find the limits. So if the function that contains f plus g model, then how to apply the limit? F minus g, f into g, and some constant into this f by g and some power rule. The next, limits of a polynomial. You know the polynomial p of x. So the polynomial of nth degree is in the form of like a0 plus a1x plus a2x square and so on, an x to the power of n. If p of x is like that, then the limit that for that polynomial at x tends to a is what? So if p is a polynomial function and it is in the form of p of x is a0 plus a1x plus a2x square and so on, an into x to the power of n. So this indicates the nth degree polynomial. So to find the limit for this function at x equals to a, where n is any number more than or equal to 1, then the limit of this function at x tends to a, p of x is p of a. Just so you need to replace this x with a. So we get so p of a. That is limits for the polynomial functions. Next, limits for rational functions. Limits of a rational function. So it is like a quotient rule only. You know the rational function, right? So it is in the form of p by q, like a rational number. So here let us consider p and q. P of x and q of x are polynomials. And here the restriction is q of a is never 0. The denominator q of a is not equal to 0, then the limit x tends to a, p of x divided by q of x. See, as we know the quotient rule. So if it is in the form of f by g, so we need to apply the limit for numerator as well as denominator. And if we apply the numerator, the limit for numerator, so we get it is p of a, right? And divided by, so if we apply this limit for q of x, so we get q of a. So the limits for the rational functions are like p by q form when q is not equals to 0. So we will solve some problems, example problems regarding these properties. So you need to compute the following limits. Number 1. So limit x tends to 1. So like it is x square plus 2x plus 7 is given. So this is a polynomial. So directly you can apply the limit. Or so by using the properties, so we can write this limit as limit x tends to, say like it is f plus g plus h modulo only. So you need to apply the limit for f, limit apply for g as well as for h. So this is a limit x tends to 1 f of x, that is x square, plus limit x tends to 1 2x plus limit x tends to 1 7 also. Now so here as x is goes to 1, then x square is 1 square plus, so it is a constant multiple. So 2 into limit x tends to 1, x is 1 only, plus limit x tends to 1 7 is a constant. So for the constant function, so it is always a constant, so that it is 1 plus 2 plus 7, that is 10. So the limit of this polynomial is 10. Number 2, limit x tends to minus 3, so 1 by x plus 2. Now so how it looks like, so it is a limit x tends to a f by g model, or it is a polynomial or rational polynomial also, no problem. So you need to apply the limit for numerator as well as denominator. So here the solution is, So we can apply this as a limit x tends to minus 3, 1 by x plus 2 as limit x tends to minus 3, 1 divided by limit x tends to minus 3 x plus 2. Just you need to apply the limit for numerator and denominator. This is limit x tends to minus 3, constant is always a constant, divided by limit x tends to minus 3, x plus 2 is there. So here replace x with minus 3, then it is minus 3 plus 2. Then so it is 1 by minus 1. So this is minus 1. So before going to apply the limit for this type of rational functions, so you need to check whether the denominator is 0 or not at x equals to minus 3. See here at x equal to minus 3, x plus 2 is non-zero. So x plus 2 is non-zero only. Next. So limit x tends to 1, it is x plus 2 into 2x minus 1. Now, so how to apply? So this is like a f into g model. So you need to apply the limit for f and g. So that is, so limit x tends to 1, f of x means x plus 2 into limit x tends to 1, 2x minus 1. So you need to apply the limit for both, or you can apply directly also, no problem. So this is x tends to 1, x plus 2 is 1 plus 2 into, so if we apply the limit for this function, this is 2 into 1 minus 1. Then it is 3 into, so 2 minus 1. So finally this is 3. 3 into then 1. So it is 3, 1. Then so example number 4. So limit x tends to 0, 1 by x square minus 3x plus 2. Then so it is like a f by g model. So now directly apply you can the limit. So limit x tends to 0, 1 is 1 divided by limit x tends to 0, this, so x square minus 3x plus 2 is non-zero when we apply this x as 0. So this is 0 square minus 3 into 0 plus 2. This is 1 divided by 0 square is 0 minus 3 into 0, 0 plus 2. So finally this is, so the limit of this function is 1 by 2. When limit x tends to 0, then 1 by x square minus 3x plus 2 is 1 by 2. Next, problem number 5. So limit x tends to, let us take negative value. Let's say x tends to minus 1. So now if it is in the form of p of x by q of x form, like it is x cube plus some 4x square minus 3 divided by x square plus 5. Now, so at x equals to 1, then x square plus 5 is not equal to 0, so there is no problem. Now, so you can apply the limit for numerator and denominator directly. So this is x square, x cube means it is minus 1 whole cube plus 4 into minus 1 square minus limit x tends to minus 1 minus 3 is minus 3 only divided by x square. So it is minus 1 square plus 5. Then see it is a minus 1 cube is minus 1 plus 4 into minus 1 square, that is 4 minus 3 divided by minus 1 square is 1 plus 5. So which is 4 minus 4 by 6. Then it is 0 by 6. So answer is 0. So the limit for this polynomial, rational polynomial is 0. Now limit x tends to 1, x square plus x minus 2 divided by x square minus x. Now, so you need to check the denominator is 0 or not. So at x equals to 1, what happens? It is 0. So we cannot just substitute directly x equals to 1. So because it makes the denominator is 0. However, so we can factor the numerator and denominator and cancel the common factor. So to obtain the limit x tends to 1 p of x by q of x. So if it is the denominator is 0, then so you need to take a common factor for numerator and denominator. So if we cancel the common factor, so we may get the exact limit for the given polynomial. But so we can't substitute directly x tends to 1 if the denominator is exist. See here 1 square minus 1 is 0, right? So that so it makes the denominator is 0. So we cannot divide with 0. Now limit x tends to 1, x square plus x minus 2 by x square minus x is there. See here, the factors for the numerator, like it is x square plus x minus 2 is there. So you can write this as x 1 into minus 2. So this is x square plus 2x minus x minus 2. Factors could divide this one. So this is x times of x plus 2. Minus 1 common is not like x plus 2. So that it is x plus 2 into x minus 1. So the factors for x square plus x minus 2 is x plus 2 into x minus 1. So this is limit x tends to 1. Now you can write it as x plus 2 into x minus 1, right? Divided by the denominator x is common. Then it is x minus 1. So here the common factor is x minus 1 gets cancelled. Now after cancelling the common factor, now you can apply the limit. Now so limit x tends to 1, numerator that is 1 plus 2. By limit x tends to 1, x is 1. So this is 3 by 1. Finally it is 3. So the limit for this is 3. So ఇక్కడ గుర్తుంచుకోండి, డినామినేటర్ 0 అయినప్పుడు కంపల్సరీ ఒక కామన్ ఫ్యాక్టర్ ఎగ్జిస్ట్ అవుతుంది. సో కామన్ ఫ్యాక్టర్ ఫైండ్ అవుట్ చేసి క్యాన్సిల్ చేయాలి. దిస్ ఈస్ కాల్డ్ క్యాన్సిలింగ్ ఏ కామన్ ఫ్యాక్టర్. Number 7. So this is limit x tends to a, x square minus a square by x minus a. Now check the limit. Here the denominator is there. So if we substitute x equals to a, therefore it is a minus a, so 0. So here so we need to factor the numerator and denominator to cancel the factor. So it is a square minus b square form. So a square minus b square is a minus b into a plus b, right? So x minus a into x plus a divided by x minus a. So here you can cancel the common factor, that is x minus a and x minus a. Now you can apply the limit. So x tends to a, x plus a is a plus a, that is 2a. So that then the limit for this function is 2a. If we apply the limit x tends to a directly, then it is a 0 by 0 form. So that is called the indeterminate form. So try to search for the common factor of numerator and denominator in this case. And so finally the last problem, limit let us take another variable, let h tends to 0. Now say root of 2 plus h minus root 2 divided by some h. Now so if the problem is like this, now say how to find the solution for this type of problems. So here similarly here we cannot find the limit by substituting h equal to 0 directly. So in this case so what we have to do, and see here we can observe the numerator and denominator do not have some obvious factors, right? So like previous, since it contains some radicals. So whereas in the previous problem, so simply you can observe the obvious factors, like it is x minus a into x plus a are the previous problem also. Now so in this case, so we need to create a common factor by using the rationalization. If the function that contains radicals, so we are better use the rationalizations. So the given limit is limit h tends to 0 root of 2 plus h minus root 2 divided by h is given, right? Now if we substitute 0, then it will be 0 by 0 indeterminate form. So that so we need to create a common factor for this, like this. So 2 plus h minus root 2 divided by h is there. Now so rationalize the numerator. So or you can multiply and divide with this term, root of 2 plus h plus root 2 divided by root of 2 plus h plus root 2. So to get the common factor, so you need to multiply and divide with this term. Right now, so this is limit h tends to 0. Now so it is like a minus b into a plus b, a minus b into a plus b, that is a square minus b square, right? So this is a root of 2 plus h whole square minus root 2 square divided by, now so this is h times of root of 2 plus h plus root 2. Now so your square and square root will get cancelled. Then finally the limit is limit h tends to 0. Now say this is a 2 plus h minus 2 divided by h times of root of 2 plus h plus root 2. Here 2 and 2 gets cancelled. Then finally this is limit h tends to 0, h divided by h times of root of 2 plus h plus root 2. Now here also we can cancel this h and h also. Now you can apply the limit now. So here the numerator is 1, h tends to 0, the 1 is 1, and the denominator this is, so root of 2 plus h is there. Root of 2 plus h means it is 2 plus 0 plus, so root 2 is a constant, h tends to 0, constant is always a constant. So this is like 1 by root 2 plus root 2, 1 by root 2 plus root 2. Here it is 1 by root 2 plus root 2. That means 1 by 2 into root 2. So the limit for this problem is 1 by 2 root 2. Okay, so if the problem is like this, or means any numerator or denominator contains radicals, so you need to create a common factor by using the rationalizations. Or in the previous, so here it seems some factors. If that does not contain radicals, so you know how to evaluate the factors for the given quadratic equation or cubic polynomial also. So dear students, I hope you understand the formal definition and the properties of limits and how to evaluate the limits of a given function. Okay, thank you.